All right, folks, you ready? Let's get started. Okay. Um, I'm debating on whether or not I'm going to include the questions. To be honest with you, I would rather include the questions. But if enough of you guys complain about it, then I wouldn't be willing to take those out. Um, anyway, we'll have that discussion. We'll have that discussion after class. Sound good? Okay, because I think that the questions are very worth having. So anyway, let's get this party started. Let's talk about, a lot of you guys were having questions about the maps. Here's what I'm going to tell you. I would totally be willing to make all of these maps due on Monday. Officially, they'll be due on Monday. However, I'm going to include them in the grade check for next week, Wednesday. So you need to do them by Monday. Does that sound fair? I'll send out an email saying that. Yes, yes. Because some of you have emailed me and said, hey, I'm really sick and I can't get these done until over the weekend. So I said, all right, fine. So I'll push everything back to Monday, but I'm going to sit down and grade them all tomorrow. So if you didn't turn it in, you might see a 0, or maybe I'll just put a no grade in there. And that just means that you still have time to turn it in. It's technically due on Monday. I'm just grading it a little bit early so that way you guys can know to turn in everything by Monday. Sound good? All right. Now, what do you need to do for the maps? The maps are actually really easy to do. I think that they're easy. All you got to do is this. Like, let's take a look at the volcanology map. Here's the volcanology map. Here's where the volcanoes are. Now, if we're looking at a closely spaced, so here's the legend and here's the map, and I have all of the maps all on top of this thing, all on top of the student template. So the legend says, if we're looking at closely spaced volcanoes so close that the red dots overlap, the line is located on one side of the plate boundary and it's parallel to the plate boundary. The plate boundary is curved or an arc shaped, and the volcanoes are inside of that curve. Okay, so let's see. I would say, wait, somebody's saying, Mr. Dalday, I have to. Oh, okay. All I'm doing is I'm kind of showing you about the maps, and I'm going to make this due on Monday. They were actually due all week this week, and I think the last one is due today, but I'm giving you guys till Monday to do it. You can turn them all into me one time. Sound good? All right. Oh, last one is due tomorrow. I'm sorry. Anyway, which one is this light blue one? All you got to do is say, okay, I would say this is definitely a curve, and all the volcanoes are so close together. That's definitely true. South America, is that a curve? I kind of feel like it's not. I would almost venture to say that. Okay, all right. So the volcanoes are on an island, are inside the curve. And then this one says the volcanoes are on land rather than on an island. So I would say that that's light, or that's red. This part is red. You know what I mean? So we'll switch over to color red, and we'll say that this part over here, it's all red. So I'm going to color that plate boundary red, and then over here's red, because all of that's on land. We cool? And then let's see, which one is blue? I would say actually this one is dark blue. And you can put the dots on that side too. They're a little bit more diffused. And then green is there's no volcanoes on this plate boundary. So almost all of the map is green. All this stuff over here is green. Maybe a little bit of red on here, but this is all pretty much green. Over in this small little arc right here, I could say that that would be light blue. And the rest of the map is pretty much green. So that's all you do. Trace out the map. Now this one right here, this bottom part, I would definitely say all of this stuff is light blue. And here, because these are arcs, and inside of these arcs, there's the boundaries. So something like that. What do you guys think? What do you mean email you those without the coloring? Oh yeah, yeah. You need to put in the dots, so the blue dots and all of that kind of stuff. I usually put the dots on the side where the volcanoes are, so you can put the light blue dots like that. Didn't I give you this sheet? I gave you this one, right? This is a part of the student. So all of these will be, yeah, it's the student thing. All of these maps are on the same file. So for the seismology map, you would turn in just this one colored. For the volcanology map, you can turn, I mean, you'll probably just keep working on the same file. So you'll turn in both, at least the volcanology one colored, and then, I mean, in the end, for tomorrow's assignment, technically you should just have them all colored and then turn that in. Sound good? You don't have this one file thing. Where does this file thing come from? It's in the plan. It's right where it says, all right, here we go. In the instructions, is it in the instructions? In the instructions, I say, yeah, you can turn them in separately. You can turn them in all one time too, and we'll see. Do we need to do the questions? Can we talk about that after class? Because I do want to get to today's lecture, and I'm already 5 minutes into my lecture. So, by the way, when you open up the seismology instructions, I think in there I give you the access to the student sheets. And that's where you'll be able to download those PNGs. Seismology map. And then if you go down and you read the instructions, it says, oh, here we go. On your Discovering Plate Boundaries seismology map, go to seismology map, the second one from the top. Color in the gray, or color over the gray boundaries and use the red. So you don't need to do this. I did this for you. You can download the student template file and edit it in Paint. So you just click on that and you download it. Or print it up and actually use color pencils. There, see? That's the files. That has the actual map with the gray lines colored over it. Does that make sense? And then and that's the one I was messing with. That's this thing right here. And then you just color over it. Are we cool? And you can copy and paste it into Paint and use it in Paint. You can also open the file directly from Paint. You can print it up and use colored pencils and actually highlight it or marker it or whatever you want. You can yeah, and you can redo your assignments and then just resubmit them. I think that the Dropbox will allow you to submit more, assignments. Just when you submit a second assignment, type in resubmit it. Anyway, hey, folks, today we're going to talk about something pretty interesting. It's called rocks, and I'll show you the place that I'm using all of this stuff, that I'm getting a lot of this stuff from, so that way if you're really sick and you need to go, that's fine by me. Let me make sure that you know what to read. Today, here we go. See this interactive rock cycle? I found that website is actually really good. In fact, a lot of the information I'm talking about today is coming straight out of there. So, check it out because it's actually a really cool cool website, and that's what we're going through. Anyway, I need to talk to you about rocks. Rocks, not all rocks are the same. Okay? Rocks can be different, and we classify these rocks basically on how they're made. We talk about we classify them based off of what materials are in them, but mostly we classify them on how the three different rocks are made. So here, I've got my big list of bunch of rocks, and we've got three different categories. This top category is actually a fourth category called minerals, which aren't rocks. Minerals are inside rocks, but here's all of my rocks. It's all of these guys on the bottom. And this isn't all the different types of rocks there are known to man. This is just the ones I've collected. I know, I collect rocks. Anyway, the top part right here, this is called the igneous rock. Igneous. Can you please type that and make sure you guys know how to spell it? Type it in the chat bar. Say igneous rock. Everyone say igneous rock. There we go. Igneous. There we go. All right. The second one is called metamorphic. That's these guys down here. Metamorphic rock. Metamorphic. Type in metamorphic. Everyone say metamorphic. All right, and the last one is this middle type right here, and that's called sedimentary. Type in sedimentary. Make sure you guys know what we're talking about here. Everyone say sedimentary. There we go. Cool. Let me show you some sedimentary rock features. Here, let's see. Lecture notes. Okay. Sedimentary rock features. Look on the computer screen. And you can see the sedimentary rock. It's formed. If you look closely at sedimentary rock, you can often see a lot of sand, some shells, pebbles, and other things kind of put in together. This put all together is called a sedimentary rock. Now, if I were to break it all apart, what would I have? I just have sand. A mess. Yeah, a mess of all different kinds of stuff. And that's, we call that, you know, the things that make up a sedimentary rock we would call sediment. Does that make sense? So what is sediment? What is the most common sediment you've seen in Hawaii? Sand. It's on the beach. Make sense? All right. Now, gradually, what happens to this sediment is the sand will kind of clump together and accumulate. And over a really long period of time and under really high pressure and all of that kind of stuff, you can actually make a rock. If I took sand and I put it in my hands and I squeezed it for like a million years, no, not that long, but I mean for a really, really long time, I would create a rock. Are we cool? Yeah, a sand rock. And the sand rock is basically a sedimentary rock. We cool? So, if you look at these rocks, like let's take a look at some sedimentary rocks. This one would probably be a good example. Can you guys see that? Here, let me get the light over there. Hopefully that. You can't really. Can you see it? All right, that rock right there is a sedimentary rock. It's called a conglomerate, and it's basically a conglomeration of all different kinds of stuff in there. You can see little pieces of cement in there, and it's basically just kind of this stuff that's kind of all hardened together. Yeah, you guys got that? All right. It looks like chocolate. It's kind of like, you know what? I'm going to go steal a chocolate bar from my coworker. I'll be right back, because I want to show you something. I'll be right back. All right. Stole a chocolate bar. Or whatever this is. What is this? This is a protein bar. Okay. This protein bar that I stole from Mr. Cop, which is a terrible person to steal from if you think about it. I mean, he's Mr. Cop. But anyway, whatever. Oh, wait, are you guys you guys are Mr. Cop students as well, huh? Don't tell Mr. Cop. Yeah, all right, because I didn't ask him. Anyway, this is kind of a conglomerate of a bunch of different stuff. There's Rice Krispie treats in here, and there's like peanuts in here, and there's chocolate all over the place. Are we cool? Apparently Natalie doesn't like peanuts and that kind of stuff. All right. How would you find out? And what happens if I? Well, I'll show you guys some other stuff. Okay. Now another rock that we can talk about, and look at your computer screen at this point, is this thing called metamorphic rock. Metamorphic rock has it's created under the surface of the earth. It metamorphosizes. When I say metamorphosis, what do you guys think of? A butterfly. Yes, a butterfly, because a butterfly changes. It changes from a caterpillar into a butterfly. Metamorphic rock changes. It's a rock that actually came from being a sedimentary rock. Cool? So it used to be a different kind of rock, and it metamorphosized into a metamorphic rock. And here's how I made a metamorphic rock. I took my sedimentary rock and I squeezed it like this. See, now it's like this. All right, hold on, I'm gonna squeeze it some more. And imagine if I squeeze it really, 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 really big. I mean, like hard. And if I squeeze it really, really hard, and I, squeeze it with a really long time and over really high heat, then this rock kind of changed into. Do you see how like the layers got kind of squished together like that? I'm gonna eat some of my rock. So that's a key feature that you would see in metamorphic rock. There's these ribbon-like layers. So here's my metamorphic rock. Here. Look at that rock. Do you see there's lines that kind of go across it? Those are ribbon-like layers. You can kind of see better in this picture over here. Ribbon-like layers. Got it? I'm choking on my rock. Excuse me. All right. So now I have my metamorphic rock, and then I need some water. I have my metamorphic rock, and I have my lamp up there. And if I hold this for a very long time, right next to my lamp, what's going to happen? The chocolate will melt. In fact, if I put this in the fire and leave it for a very, very long time, the whole rock will melt. Right? It will melt. And when it melts, say that it all melts together. I didn't burn it, I just kind of heated it up. It doesn't make igneous rock, as Jenna is saying repeatedly. It actually makes this thing. What is melted rock? What do we call that? Magma. There we go. It's magma. It will turn into magma. That's liquid rock. We're talking about melted chocolate here. Now, when liquid rock cools, when magma cools, so like if I take my melted chocolate, that's just this, pan of melted chocolate, and I put it into the freezer, what's going to happen? That's when we're going to create like hard rock. Actually, it would be a hard mixture of rock and Rice Krispie treats and peanuts, and it would harden, and that would create a different kind of rock. And that right there is what Jenna is referring to. That is called an igneous rock. Vernon's asking, what is obsidian? Obsidian is actually a type of igneous rock. Can you guys see obsidian? What do you notice about obsidian? It looks like glass. It's dark. It looks like, yeah, it's shiny. That's a characteristic of igneous rock. Now, in Hawaii, have you ever seen an igneous rock? No. No. River rocks? No. Yeah. Lava rocks. Okay. I would say that like almost all of the rocks in Hawaii are pretty much igneous rock. Because I mean, if you think about it, Hawaii has what? Where do all of our rocks come from? From lava. Yeah. From volcanoes, right? The magma that comes out, and when the magma comes out, it forms this kind of rock. It's called basalt. You've seen this before. You've probably walked on it. And if you're from the Big Island, this is all there is. Right, Jenna? Yeah, that's basalt rock. And so, what are some features of igneous rock? Well, they have gas bubbles a lot of times, depending on how they're cooled, right? And they also have, they'll look shiny. They could look shiny. They don't have any crystals inside of them because how do they form? They formed from liquid rock turning into something else, so we didn't put anything inside of it. Um, and and yeah, those are really cool. Those are really cool. All right, so what are some features that we can look for in rocks? We can look for crystals. So I told you that minerals aren't rocks; they're minerals, but they can be found in a lot of rocks. Like for example, this one right here has a lot of crystals in it. I think you can see better in the pictures because you can't see my camera as well. What do we look for? There's crystals. You can also find fossils. Now, if we find a fossil, what kind of rock are we talking about? What kind of rock do you think I'm talking about if I find a fossil inside? Sedimentary. Why sedimentary? No, no, the answer is sedimentary. Because it formed from animal parts. Yeah, yeah, yeah. Something died. You got a bunch of sand over there and some other rocks and other stuff, and then it kind of just gets pushed all together, and you can actually see the dinosaur bones inside of the sedimentary rock. Does that make sense? All right. What about another thing to look for is what else can I look for inside my rocks? Gas bubbles. If there's gas bubbles, what kind of rock am I talking about here? Swiss cheese. Swiss cheese rock is very good. Also known as igneous rock. There we go. If it looks like glass, that's another one. That would be the obsidian ones that we're talking about here. Obsidian. Looks like glass. Also talking about other igneous rocks. What happens if it looks like this? What feature is this showing you, that picture right there? And what kind of rock is that? Just by looking at the rock. You're saying it's a metamorphic rock. How can you determine it's a metamorphic rock? Because there's layers. Metamorphic rocks are like onions. And onions have layers. Quote from Shrek, although he said ogres are like onions. But anyway. I mean, I'd rather have an ogre like a parfait, but, you know, whatever. Okay, what else can I talk about? Oh, yeah. They have stuff inside. Now, this kind of rock, what was it called again? That's this rock, actually. That's a close-up picture of this guy. It's called a sedimentary rock. This particular type of rock is actually called a conglomerate because which is a type of sedimentary rock, which is just, you know, a bunch of stuff put together. Kind of like this. This is more of a sedimentary rock. Cool? Alright. So let's talk about rock processes. Rock processes. Alright. If I take... Yeah, I hope I don't choke. Let's talk about heating and pressure and all that kind of stuff. How do rocks change? Okay. So when I take cookie dough and I put it into the oven, I produce a different kind of cookie. Actually, the heating process and the pressure process interact, and they melt the dough and they change it into a whole different product, and we call that a cookie. So I can turn an igneous rock into a metamorphic rock by melting it and heating it. So this happens beneath the Earth's crust, and where about 62 to 124 miles below the Earth's surface, and this is where the Earth, this is where it's hot enough to actually melt most rocks, and rocks can actually change and be morphed into from one point or from one type into another. All right, another type of thing that we could do is we can just straight up melt it. Now, if we take a metamorphic rock or an igneous rock and we melt it, what does that do? That will change it into what? That won't change it into igneous. It will change it into what? It will change it into magma. There we go, molten rock. Magma. All right. That molten rock can then harden, and it will turn into igneous rock. So when rock melts, it doesn't turn straight into igneous rock. Sure, the next rock after that comes after that would be igneous rock, but before that, it's molten rock or magma. Got it? All right. What's another process that can happen? After a rock melts, and it's magma, where does it go? You're really good. I'm getting sediment all over my floor. I better pick them up before I have time. A volcano, there we go. It goes to a volcano. So the magma gets shot up out of the volcano. And it cools down, and that's the process that we need to talk about. Cooling. There we go. And when it cools and it creates the rock outside, what kind of rock is that? Igneous rock. It's like our favorite rock because pretty much all of all of the Hawaiian Islands have igneous rock all over. In fact, I can't even really think of where you would find metamorphic rock in Hawaii. The Big Island is just a giant igneous rock. In fact, that's what all of Hawaii is. So anyway, I better stop eating my rock. When an igneous rock is created inside the Earth, like for example, when it's slowly created, it doesn't erupt out of the volcano, but it's created underground, and then it's slowly pushed up out of the Earth. What that's called an intrusive igneous rock. But if a rock is created outside, like here's the volcano, and then magma comes out, and then the rock is created, that's called an extrusive igneous rock. Does that make sense? Intrusive, extrusive, we're cool with this, right? All right. Um, one last one I can think of is, oh, I need to talk about weathering and erosion. I don't think that I have a slide on that, but anyway, oh, here we go. Weathering and erosion. Say that I took my rock and I melted it. Okay. So say that's a sedimentary rock, and then I squeeze it. Squeeze.
Hands on there now, but whatever. I've now created a metamorphic rock. And then I melt it.
And I put it in the freezer. I've now created
An igneous rock. Well, I melt it and then I create magma.
and then that magma gets shot out and hardens, and that's now an
Igneous rock. Yes, this is the same bar. I just ate most of it. Alright.
now when it's outside, what happens to it? It erodes. It cools. Yeah.
Well, it cools, yes, and then it creates the igneous rock.
It melts. It doesn't necessarily melt outside, but it erodes away.
Like the rain. Like if I were to put this under the water faucet, what would happen to this thing? If I were to actually take this
Candy bar, that's my new igneous rock, and put it under the water faucet and leave it for 3 days, what would happen to it? It would break apart. There we go. And when it breaks it apart, it turns into
what?
Starts with an S. If I take this and I break it apart, whoa. What is it going to turn into? It's going to turn into sand, which, not sedimentary, it turns into what we call sediment. It's the stuff that makes up the sedimentary rock. So it turns into sand. So here's my sand.
Got it?
And then, after a long period of time, I better put my sediment on the side. After a long period of time, it's kind of, that happens, and then a little bit more of that. There goes my paper. There we go. A little bit more of this. Looks like poopy now.
Don't tell me that after I'm going to eat it.
Alright, there we go. It becomes a sedimentary rock. Are we cool? And by the way, how did it get crushed together? Well, we call that compacting and cementation, or cementing. Imagine if all this sand fell to the bottom of the ocean. And when all this sand gets thrown to the bottom of the ocean, what happens when you go to the bottom of the ocean? It's crushed. So my sediment got crushed into sedimentary rock.
Does this make sense to you?
That's the end of my rock, but anyway. Do you see? Yeah, it still tastes the same. Do you see how all of these rocks are made up of each other? Like I've got one rock that turns into the other rock that turns into the other that turns into the other. Now, here's what we have. Here's what we made. So let me show you. Ready? I want you to draw this. Draw this picture. And I'm almost done. I'm almost done. I'm going to take like 5 more minutes of your time. You ready? We start off with magma. Okay? Magma is molten rock. And then the magma can cool. Right? And what does that make, Jenna? Because this is one of your favorite parts. Someone else can answer it, not just Jenna, but what does cooling magma make? Igneous rock, there we go. Alright, so now igneous rock. What can happen to the igneous rock? Well, we can do two things. We can melt it, And that would turn it back into magma. Or we can weather it. Erosion. Got it? And if I weather it in erosion, what would that turn it into? It will turn my igneous rock into what? What do you find on the beach? Sand, sediment. Not a rock yet, but just, a bunch of junk. It's sand. Now, what can happen to that thing through a process called compacting or cementing? We can now make sedimentary rock. You guys got it? All right. Now, what can happen to that sedimentary rock? Well, we could weather and erode it again. And what does that do? Well, it would turn my sedimentary rock back into sand. I could break apart that sedimentary rock and then it becomes sand. Yeah, sediment. But what I can also do with sedimentary rock is I can heat it. Heat. Pressure. And that will turn it into metamorphic. Does that make sense? Now, what can I do to my metamorphic rock? Well, I can weather and erode it again, and that would turn it back into sediment. Or what I could do is I could melt it, and that will turn it back into magma. There we go. And there's one more piece that I'm missing. It's if I take igneous rock and I apply heat and pressure, just like I applied heat and pressure over here, that will turn it into a metamorphic rock. So my rocks are as follows: sedimentary, metamorphic, igneous. And my processes are, let's go with light blue: melting, cooling, melting, heat pressure, weather erosion, compact and cementing, heat and pressure. And then the stuff I have left over is the magma, which is molten rock, and the sediment, which is just sand. Make sensey? It's the circle of rocks. Okay, I won't. That's the last time I'm ever going to do that. But you have it on recording. So if you want to, you could, watch it again and again. Bazinga! All right, what do you guys think? Does this make sense to you? Like, this actually is what happens. I think that that's pretty cool. A little? All right, read up on it. Check it out. You'll find that what I'm talking about is not crazy. And then I'm just talking about it in a crazy way. And then after you read up on it, make sure you guys do the quizzes and whatnot. All right, cool. I'm going to stop the recording. Does anyone have any other questions?